Welcome back to this FP1 video. This one is proving divisibility results using proof by induction. And the process is very similar to the last video, okay? But instead of the summation formulas, we're now going to look at, proving that something is divisible by 4 or divisible by 12 or whatever the question may be. So I think without beating around the bush, let's get straight into the first example. And here it is. So prove by induction that for all positive integers n, 13 to the power n minus 6 to the power n is divisible by 7. So the first thing, it's the same kind of steps as before, n equals 1, the basis step, assumption step, inductive step, and then the conclusion. Okay, so first I'm going to start off with let f of n equal that 13 to the power n minus 6 to the power n. Okay. You don't have to put this bit in, but where n is a element of the positive integers. Okay, so that's what we're going to start off with. And then the first step is, when n is 1. So we're substituting 1n, so f of 1 will give me 13 to the power 1 minus 6 to the power 1, which is 13 minus 6, which is 7, which is divisible by 7, isn't it? Kind of obvious, but I'm just getting you used to writing these bits down, So f of n is divisible by 7 when n equals 1. Now we do the assumption part, so assume true for n equals k. So we proved it for 1, we're going to assume it's true for k, for all values. And then we're going to, show it's true for k plus 1. And then when k is 1, we've shown it's true for k equals 2. And so on. Right, where was I? So f of k is 13 to the power k minus 6 to the power k. So that is now my first two steps. N equals 1, my basis step, and then my assumption step, n equals k. Now my next step is f of k plus 1. Okay, so this one now is going to be 13 to the k plus 1 minus 6 to the k plus 1, which is 13 times by 13 to the k minus 6 times by 6 to the k. Remember, I can split these up because if you remember your laws of indices, this is 7 because it's 3 plus 4, isn't it? 3 plus 4. So I can split them up. Split up this into that. So there's k plus 1, 6 to the power k, times by 6 to the power 1. Okay, now what I want to do is take away f of k from both sides. I'm actually going to continue up by here. So, well, I'll write it down here, but we're going to do f of k plus 1 minus f of k. Okay, and then we've got that 13 times 13 to the k minus 6 times 6 to the k minus f of k. So f of k plus 1 minus f of k is 13 times 13k minus 6 times 6k minus, now f of k is 13 to the power k minus 6 to the power k. So I've got 13 of these, taking away 1 is going to give me 12. So 12 times 13 to the power k. Now I've got 6 of these, minus 6 of these, and I'm plussing 1. So that's going to give me minus 5 times 6 to the k. Okay, now I got 5 of these and I'm going to take 5 out of these. I'm going to take an extra step in this first example, okay, just to show you what I'm doing. But I'm going to split this up into 2. So it's going to be 7 times 13 to the k plus 5 times 13 to the k. Okay, so these two obviously add up to give me the 12 minus 5 times 6 to the k. So that's 7 times 13 to the k plus 5, and that's 13k minus 6k. Okay, so what I've now got is 7 times 13 to the k plus 5, and this is f of k. And I've still got f of k plus 1 minus f of k here. Now let's bring this f of k to this side. So f of k plus 1 is 7 times 13 to the k plus 6 f of k. Now you can see that this is divisible by 7, isn't it? Because f of k is divisible by 7. So 6 lots of something divisible by 7 is still divisible by 7. And then this is divisible by 7 because it's 7 times something. So this whole thing is divisible by 7. So then we write that sentence. Therefore, f of n is divisible by 7 when n equals k plus 1, because we've shown it. Now, final step is to write our conclusion. So I'm not going to speak it and write it at the same time, because you know how that goes. It usually goes badly for me. So in a second, and there we have it. Okay, so if f of n is divisible by 7 when n equals k, then it has been shown that f of n is also divisible by 7 when n equals k plus 1. As f of n is divisible by 7 when n equals k, f of n is also divisible by 7 for all positive integers of n by mathematical induction. Sorry, I just had to squeeze it in there at the bottom. Okay, so this is basically what you're going to do now each time. Now, when I took away the f of k from both sides here, you don't actually have to do this step. But if you do take this step, it does work every single time. You can do it straight from factorizing up here. And when you factorize up here, basically, because this is divisible by 7, you want to take 7 out of both of these. Okay, so taking 7 out of this one and 7 out of this one. And then playing with what you basically have left. Okay, so you can do it that way, but I find that taking f of k away from both sides, it works every single time. So, you know, you just need to learn then one way of doing it, and then, you know, you won't have a problem. Okay, so I guess it really depends on, you know, you and, you know, how quickly you're understanding these, to kind of whether you want to do this way or whether you just want to do it by factorizing. So I'll have a look at another example, and maybe I'll try and show you that other way in the next one. Okay, let's have a look at a second example. So let's start off the same way as last time. So let f of n equal 3 to the power 2n plus 2 plus 8n minus 9. And then I can put this in at the end where n is an element of the positive integers. But, you know, if you don't remember that bit, there's nothing to worry about. So first step is substituting 1 in. So 3 to the power 2 times 1 plus 2 plus 8 times 1 minus 9. So this is 3 to the power 4 plus, no, minus 8 minus 9, so minus 1. 3 to the power 4 is 80. 1 minus 1 is 80. And this is obviously 8 times by 10. So it's divisible by 8. So, oh, I should say therefore, shouldn't I? Oh well. Divisible by 8 when n equals 1. Now assume true for n equals true. Okay, assume true for n equals k. So f of k is going to be 3 to the power 2k plus 2 plus 8k minus 9. So that is my f of k. Now we want to do our f of k plus 1. So 3 to the power 2k plus 1 plus 2 is 8k plus 1 minus 9. So we've got 3 to the power, so we've got 2k plus, so that's now 2 plus 2 is 4, isn't it? Plus 8k plus 8 minus 1, minus 9 is minus 1, isn't it? Okay, so 3 to the 2k plus 2 times by 3 to the power 2. So what I'm doing there is I'm splitting the 2k plus 4 up into 2k plus 2, so that I'm going to be able to swap for this at some point. Plus 8k minus 1. Now let's take f of k away from both sides. So taking one away, I've got 8 of these now. So 8 times 3 to the power 2k plus 2. 8k minus 8k is 0. And minus 1 plus 9 is 8, isn't it? Oh, there we are. This is nice and easy. So we've got 8 lots of 3 to the 2k plus 2 plus 1. So this now is divisible by 8. Oh, I'm just getting a little bit ahead of myself because what I haven't done is taken the f of k back over to the other side. So this is just f of k plus 1. So it's 8 times this plus f of k. Okay, so now I can say therefore f of n is divisible by 8 when n equals k. Okay, and then to follow it up then with the conclusion, very much like the first example. And here it is, the same as what I wrote last time, but this time I'm just putting in the 8s where the 7s were. So f of n is divisible by 8 when n equals k. Then it's been shown that f of n is also divisible by 8 when n equals k plus 1. As f of n is divisible by 8 when n equals 1, then it's also divisible by 8 for all positive integers. That should be a plus there, by mathematical induction. So that is now our process. I wasn't able to show you just doing it the slightly other way with this, but maybe one of the questions I set you in a moment, I'll have that opportunity. But hopefully you've understood this now, but it is time to have a go at a couple yourself. Both of these examples were past paper questions. I'll just give you 2 or 3 questions to have a go yourself. They'll also be past paper questions. Okay, now if you watched the video up to this point and you're not a subscriber, hit that subscribe button now. If you're finding this video useful, I'm not saying you like it, but finding it useful, smash that like button. And if you are a long time viewer of my videos and you wish to give something back to me, then please consider hitting that join button, even if you join for just 1 month. It all helps me out. Thanks guys. Now let's look at the questions. Okay, here they are, just 3 questions. I don't think you need to practice any more at this point, but of course you have your textbook, you have plenty of questions online. You can use ChatGPT. I don't know what it is, struggle saying it. You can use that to put in some questions and ask it to make similar questions, just to challenge you that way. So pause the video now or around now, have a go at the questions, and then stay tuned for the answers at the end. Okay, let's start. So let f of n equals 8 to the power n minus 3 to the power n. And then what we want to do is substitute 1n, so f of 1 equals 8 to the power 1 minus 3 to the power 1, or 8 minus 3, which is 5, which is divisible by 5, isn't it? So f of n is divisible by 5 when n equals 1. The same true for n equals k, so that f of k is equal to 8 to the power k minus 3 to the power k. Okay, now we're going to look at our f of k plus 1. So that is 8 to the k plus 1 minus 3 to the k plus 1. So that is 8 times 8 to the k minus 3 times 3 to the k. Now, subtracting f of k from both sides. So if I take away 8 to the k, I'm going to get 7 8 to the k's. And then if I add 1, because it's minus and minus, so I add 1 3 to the k here, it's going to become 2 to the k. 2 times 3 to the k, I should say. Now I'm going to carry this on here. So I've got 7 and I've got 2, so I can take 2 of them outside. So 2 times 8 to the k minus 3 to the k. And that leaves me with 5 times 8 to the k. And then this 8 to the k minus 3 to the k, well, that is just f of k, isn't it? So we get 2f of k plus 5 times 8 to the power k. And then add an f of k from this over here. We get 3f of k minus 5 times 8 to the k. Plus 5 times 8 to the k. Therefore, f of n is divisible by 5 when n equals k plus 1. And there we have it. So our conclusion as normal. However, I just want to back up a second to here. So going back to this bit, if I didn't want to take away f of k, I could split this one up into 5 times 8 to the k plus 3 times 8 to the k. And that gives me 5 times 8 to the k plus 3 lots of 8 to the k minus 3 to the k, which is 5 times 8 to the k plus 3 of f of k. Okay, so that is by factorizing. And you can see you get the same answer for f of k plus 1, 5 times 8 to the k plus 3 f of k. So, you know, it can save a lot of time by doing it this way, factorizing, but it doesn't always work with every question as simply as it did here with this one. Okay, some questions require quite a bit more work and manipulation. And when you're under exam pressure, I worry that a lot of people might struggle with that. Now, some of you are very good mathematicians, and some of you are good mathematicians that work very hard. Okay, and there's nothing wrong with either of these, but you know, if you're someone who does struggle when you're under exam pressure, then stick with always the minus in f of k from both sides. Okay, if you're someone that can cope with under pressure, or you fully understand this, you know, you're gifted in maths and you can adapt to using multiple methods, then pick the method that works for you at the time the quickest and easiest way, because what I've just shown you here, this works quickly and easily for some questions but not for others. Anyway, let's get on with the final question. Not the final question, question 2. Right. Maybe I shouldn't have made a video today, you know, with constantly saying plus, minus, minus, plus. It's just annoying. And then final question when it's the second question. Anyway, I know you guys forgive me for this. It's all part of the charm, isn't it? So, as usual, let f of n equal what the expression that we've got, and then we want to substitute n equals 1n. So that is 2 to the power 5 to the power 2 times 1, 6 times 1 plus 8. So this is 25 minus 6 plus 8. So it's 27, and that is 9 multiplied by 3. So therefore divisible by 9. And then we want to assume true for n equals k. And then f of k plus 1. Okay, so this is going to be 5 to the 2k times 5 to the power 2 minus 6k minus 6 plus 8. So that's 25 times 5 to the 2k minus 6k minus 2. Sorry, it's plus 2, isn't it? Minus 6 plus 8 is plus 2. Now this is one of those ones where it's not, you know, obvious what to do without taking away the f of k. You can do it, but it's not obvious, you know. So 25 times 5 to the 2k minus 6k plus 2 minus f of k. So it's 25 of these minus 6k plus 2 minus, and then this is 5 to the 2k minus 6k plus 8. So 25 of the 5 to the 2k minus one of them is 24. Times 5 to the 2k minus 6k plus 6k 0, 2 plus 2 minus 8 is minus 6 there. So let's see where we can go from here. Now guys, when we get to this point, it's not as straightforward. So for example, I could take 6 out of the 5 to the 2k and of the 6, and that'll leave me with 18, 5 to the 2k. That's good, but this doesn't help me. I need, you know, this and the 8 in it, don't I? So this, as it stands, isn't actually helping me. So let's take it back and let's look at another way. So the only way I can see forward, and make comments down below if you spot a way forward that isn't what I'm doing now, but the only way I can see forward is to get this f of k in. So I want 24 f of k's. So 24 times 6. So we want minus 144k. That means we've got to add on 144k because that would give me 0. And then we want 24 times 8, which is 192 minus 192. Now I can take 24 out, and I've got 5 to the 2k minus 6k plus 8 plus 144k, and I've got 19 minus 192 minus 6, so minus 198. Now 144 divided by 9 is 16, and 198 divided by 9 is 22. So there we have now 24 f of k plus 9 lots of 16k minus 22. So I couldn't see any other way of doing that. To be honest, the minus in the 5k in this case, I probably should have done it from here. Anyway, let me just take that 5k from the left over to the right. So we've left with k plus 1, f of k plus 1 equals 25 f of k plus 9 times 16k minus 22. Yeah, I probably should have done it from this point. When I realized taking away the f of k in this case didn't really make sense, I should have gone from this point and taken 25 outside and made an f of k and then dealt with what was left. Okay, now all that's left is to say that this works for n equals k plus 1 and my conclusion. Okay, I've just shrunk the conclusion down a little bit just to squeeze it onto this one page for you guys. Okay, so that is question 2. Let's have a look at question 3. So let f of n equals 2 to the 6n plus 3 to the 2n minus 2. And then substitute 1 in, so 2 to the power 6 plus 3 to the power 2 minus 2. So 2 to the power 6 is 64 plus 3 to the power 0 is 1, so that's 65. So that is 13 times 5, or I should say it the other way around, 5 times 13. Therefore it's divisible by 5. F of k equals 2 to the power 6k plus 3 to the power 2k minus 2. Now let's substitute f of k plus 1 in. So we get 2 to the power 6 lots of k plus 1 plus 3 to the power 2 lots of k plus 1 minus 2. So this is 2 to the power 6k times by 2 to the power 6 plus, now we've got 3 to the power 2k plus 2 minus 2, so 3 to the power 2k. So that's what we're left with there. 2 to the power 6 is 64, so 64 of these plus 1 of these. So let's go ahead and take away f of k, see if hopefully it works with this one. I can't believe I said earlier it works for all of them, and then we came across one that it didn't work for. Although if you guys did spot something I missed which would have made it work, then please let me know in the comments down below. What's this? 2 to the 6k plus 3 to the 2k minus 2. That's 2k. Okay. So we've got 63 of these. Oh, that's a 3 there, not a 2, sorry. Now, I've got 3 to the 2k. Now, if I want to multiply by minus 2 and multiply by 2, because these two, like 3 to the power negative 2 times 3 to the power 2 will just give me 1, so that's like multiplying by 1, and then I've got minus 3 to the 2k minus 2 over there, so this one. So we've already taken this one away from the 64. Now that's just multiplying by 1, but these two are combined to one of those. So this is going to give me 63 times 2 to the 6k plus 9, that's the 3 squared, times 3 to the 2k minus 2, minus 3 times 2k minus 2. So 63 times 2 to the 6k plus 8 times 3 to the 2k minus 2. Now let's factorize the 8 out, so that gives me 2 to the 6k plus 3 to the 2k minus 2, which is my f of k, and 63 minus 8 leaves me with 55 of these 2 to the 6k's. So I've got 8f of k plus 55 of these. Then let's take the f of k that is here to this side, so that is now 9f of k plus 5 times 11 times the 2 to the 6k. Okay, which is now divisible by 5, and therefore we have proved it. All that's left is just to put in our conclusion. And of course I've made it smaller again just so I can squeeze everything onto this page here that you can see it all. Okay, so that is now proof by mathematical induction of the divisibility ones. So all we've got left to do now is matrices, and I think that's it. There's the one in between. Oh yeah, recurrence relations. So recurrence relations and then matrices, and then we are done with this chapter and we're done with FP1. So stick around, don't forget hit that bell icon if you are waiting for me to upload these videos, because I am quite inconsistent at the moment. I will be trying to improve that, but at the moment I am a bit inconsistent.